Welcome to the Analytics Power Hour. Analytics topics covered conversationally and sometimes with explicit language. Here are your hosts, Mo, Michael, and Tim.
Hey everybody, welcome to the Analytics Power Hour. This is episode 215. You know, what is a podcast really but a set of conversational elements constructed into an audio format? And we swap out the components from time to time, like for instance, guests who come on the show, and sometimes like this episode where we're doing a little bit more, and we run episode after episode and we observe the results. I mean, it's not a simulation, but if we set it up in a systematic way to answer some sort of question, like whether Tim should warn guests about the rock, flag, and eagle at the end of the show or not, well, then we could run some simulations. Let me introduce my co-hosts, and we can talk more about it. I am really excited to introduce my guest co-host for this episode, Julie Hoyer. Welcome, Julie.
Hi, Michael.
You want to try that again with a little more enthusiasm? Easy there.
Yeah, sorry, I choked on my coffee right when you called my name.
No, that's totally okay. What I feel really awesome about Julie is that I technically am responsible for hiring you originally, and
yes,
I was like, oh, I feel really proud of that. I was just like, that was a way smarter move at the time than I even realized. So welcome. It's so awesome to have you. Julie is an analytics manager at Search Discovery, and you've also heard her on some previous episodes, and we're so delighted for you to be here co-hosting with us as Mo is out. And it's awesome that you're here specifically for this episode, I think, too. And Tim, Tim, I don't know that I'm as excited to welcome you to the show, but I think it's just because we've done it so many times before, so it's okay. Welcome, Tim.
Hi.
I know you're excited about this topic.
Hi, Michael.
Yeah, exactly. So it's the love is
Very
still there.
excited to be here. Okay.
Yeah,
I promise.
The love is still there, Tim. Okay, so yeah, but Julie, I mean, since you do have a master's in applied mathematics, I think this is actually perfect for this episode. So I'm really glad you're here. So, anyways. We did also want to bring in a guest to help talk about this topic of simulation, somebody who could open up this world a bit more for us and for our audience. Frances Sneddon is the Chief Technology Officer at Simulate, where for almost 25 years she has helped organizations leverage simulations to improve all kinds of processes and business functions. She's the co-chair of the Heads of Analytics and Operational Research Forum for the OR Society, Operational Research Society. And lucky for us, today she is our guest. Welcome to the show, Frances.
Hi, thank you for having me.
It's delightful. Also, I think to start, there's a very important question that we probably should start with. What exactly is a simulation?
And are we living in one?
Yeah.
No.
Oh, yeah, no. See, the whole podcast, I avoided that in the intro so much, Tim.
Oh, I think that is a very, very good question, because simulation is one of these terms that can mean so many different things to different people. My kids play simulator games. They go down to the arcades and they play the flight simulators. You have pilots that are being trained in airplanes. So you've got all these different types of kind of simulation. But the type of simulation that I focus on, and admittedly a bias, but I think provides the most benefit to businesses, is what I'd call process simulation. And that's the ability to look at any process within an organization, within a business, and be able to create a simulation of it so that you can experiment with it and say, what if I double my staff? What if I double the amount of work coming in? Experiment with it and know what's going to happen in the future before you implement it in the real world. So a simulation, at the heart of it, whether it's a game or whether it's for business, it's about an environment you can test in and experiment in safely.
So you're like using flight simulator as an example. I mean, not necessarily the type of simulation, but I think of flight simulator as being, or even SimCity or The Sims or whatever it's called, like they're at the core, the process has to be kind of fully modeled, like all the rules of the interactions. Is that in kind of a business or government or another, the context that you work more in, is that still like the core of it? Is you have to essentially have built out kind of all the connection points, and then when you're experimenting, you're saying, what if this was bigger, this was smaller, this was faster, and how would it ripple through the rest of the system? Like, is that fundamentally what's happening?
Yes and no. So you can build simulations in that way, and some people do them, and you maybe build them at an organisation level. But the key thing whenever you're building a simulation, we always sort of advocate is, what's the question you're trying to answer, and then you build the simulation to the right level to represent it, to be able to answer that question. So an example might be, okay, I want to decrease the waiting times for patients in the hospital in my ER department. So then you need to model the ER department, and you will have patients arriving and they'll pass into other departments in the hospital. But actually the rate that they arrive in and how the other parts of the hospital perform doesn't really help me answer kind of the key kind of question. So I can almost put them out of scope. So it's a big part, and it's a big part of what makes the difference between a usable simulation and an unusable simulation is really understanding the scope. What question am I answering? And only make the simulation as complicated as it needs to be to answer that question.
Do you ever find it hard to get down to like the question they're trying to answer? Or do you have, I guess another way to ask this, because I feel like we run into this a lot, we want to work with your company and we want a model, or we want to do machine learning. Like they choose the tool before they decide like why. Do you ever run into that with simulation where they're like, well, we want you to build us a simulation. And you're stuck asking them, well, why? Well, why? And it's really hard to like boil that down. Do you guys run into that much, or how do you propose simulation to the different clients that come to you?
Yeah, no, I think that's a common problem. I think that's a problem with probably any analytic kind of type tool or sort of anything that you kind of use. And so we'll say a lot. What we typically see from people is that sort of idea, okay, I want to improve my waiting times in the hospital, and so therefore I want to build a simulation of the entire hospital. And they want to make it so complicated, and they want it to answer every possible question they might have in 5 years or 10 years. So it's almost like, the best way I could describe it is they come with almost like an IT project mindset of, I'm going to write this specification. And that's, if a simulation's done well, that's not typically how it should be kind of done. And so it is that about that discovery, right? Okay, what is the question you're trying to answer? And like you say, kind of asking why kind of a lot, and seeing this as more of a journey, a learning journey that you're going to go on, rather than sort of building kind of an IT kind of tool. So yes, and in my early days of doing consulting, that's some of the kind of the hardest parts, is just getting people down to that one question that they're trying to answer. But one question then leads to another and another. So there's also a preconception that you build one simulation, and you often don't. It's maybe a series of simulations that you're building, because you've built one, you've learned something. Now there's another question I want to answer. Sometimes the same simulation will be able to answer it, sometimes it won't, and then you'll move on to kind of the next kind of one. So it's a journey of discovery.
So the hospital wait times is kind of a interesting one. I mean, I could see like a Six Sigma black belt coming in and saying, oh, the way to solve that is we map out the process, and then I'm not a Six Sigma deep knowledgeable person, but like they would come at it and say, it still comes to, we have to understand what the process and what the inputs and the outputs are. And then we'd measure it. And maybe it's, well, yeah, there are different ways to solve the same problem. It feels like a simulation would say, yeah, we still have to figure out by mapping out the core part of the process and figure out the constraints. But now you actually get to see, instead of somebody doing a math formula and saying, well, if we increase this by 20%, then in theory, this other thing would go down. And at the end of the day, we've done the math and said that this will reduce wait times. With a simulation, it feels like you give a little bit more of a tangible, hey, let's build this virtual world, and let's try that universe and just see what happens. Like, how much of it is what's easier for the stakeholders to actually process, internalize, buy into, to the point that they say, okay, now let's go make that change? Does that question make sense?
Yeah, I think there's a few kind of questions in.
Okay.
So bringing it back to kind of the core, you're right. You know, somebody that was doing sort of a Lean Six Sigma project, they'll probably come in and they could map out they'll map out the kind of the flow of work, and then they've got some mathematical kind of techniques about where's the wastage, where's the non-value add kind of steps. Here's some of the tweaks that they kind of make. And they can make some assumptions and some predictions about how, if there's some changes they want to improve, the impact that they'll have. And people definitely use simulation in that way, and it's valuable to do that. I think sometimes what the simulation highlights is, and partially because of the way things are modelled in it, is it can catch things that other techniques can't. So when somebody kind of maps out a process, they can map it out and you can see the rules whereby somebody kind of goes whichever kind of way. We will push through that flow diagram, though, all the individual patients. And when the patients are coming in, don't get worried, it's anonymised data, so it's not about the actual kind of patients, but it's representations of the patients. But we can then kind of say, right, okay, well, this patient's male, he's 35, he's got a broken leg, he's previously had this kind of type of condition, so he's going to go through this kind of path in the A&E department or the ER. And we can say then the next patient, she's female and she's 6 and she's got bad stomach pains, right? Okay, where she's going to go through. And so what the simulation can do, and then there's all these kind of complicated rules, is it sometimes kind of expose that, okay, in theory, the improvement that you thought was going to do is going to work, but actually, because of sort of the dynamics of the patients that are kind of coming in, maybe at different times of day, it's going to perform differently as well, because, you know, you get peak times of peak flows, or because it causes a bottleneck in some other kind of part of the process. So you'll exhibit and catch things that other techniques won't. But I think where simulation really then kind of comes into its own is that you can really experiment with radical ideas. It doesn't just have to be, right, okay, well, what if we sort of decrease the time they're spending in the cubicle by 10%? You know, what's the output of that? So an example of that, so one of the great ideas I heard one time from a sort of healthcare provider was saying that, right, okay, what happens is somebody comes into the emergency department and they are treated by a series of junior doctors who assess and sort of figure out what tests that they're going to do. They're doing this barrage of tests to figure out what they think is the likely kind of illness for the patient. And then eventually they get access to a senior doctor or consultant. What if the consultant was the first person that saw them? And so the consultant, with their 25, 30 years of experience, can sort of look at and get gut instinct, actually, do you know what? We're not going to do those 5 tests. I'm pretty sure it's just these 2 tests that we need. What would that do to the process time? Now, that's the type of thing that you can't just do by having mapped out a process and sort of saying, like, okay, if there's a 10% gain here or a 20% kind of gain there. So you can radically test that idea. You can stress test it out. And then you've also got this communication tool to sort of take to stakeholders, take to management, take to the staff in the process as well, and say, look, this might not seem like the most sort of intuitive idea, but look what it delivers. What do you think? And maybe that's not the end result, but then we start to have a conversation and say, right, okay, well, I see where you're going with that. That's flawed because of X, Y, Z, but tweak it this way. And it does start to work. So suddenly we're doing sort of step change process improvements more than just sort of incremental sort of little kind of gains.
So let me ask on that one. So that example, it does think that if you shifted that part of the process, it's an unknown as to whether, if say they've looked at the data and said on average we run 5 tests before it goes to the senior consultant, without knowing, there's kind of an idea or a hypothesis that if the senior consultant started, that they would likely, and there may be some anecdotal evidence. So is that still become sort of do you wind up with the core of saying, we think that if we shift this order, you know, it might be that, like, what would happen if that only reduced the number of tests by 10%, then that may cause, so is that you kind of bake in, or saying if we made this change, we know there's uncertainty as to what might actually happen at that change point. So we simulate a range of possible, what if we reduce the test by 80% versus 20%? And
Yeah.
And kind of run the simulation and say, what's the variability of the result? Is that how it works?
Yeah, exactly that. So if you've not got the concrete kind of evidence kind of there, so then you're effectively doing sensitivity analysis and saying, right, okay, what if we reduce it by 10%? What if it's 20%, 30%? And you can go all the way up. So then what you've got is you can actually say, right, okay, in best case, if we reduce it by 80%, here's the gains in the process performance. Worst case, here's the gains in process performance. And that might mean you discount the idea, but you're able to validate and give a sort of an ROI sort of prediction of the sort of the changes. And that might mean that idea becomes the 10th one that you're going to try, and you're going to try the other 4 that are in the list. So a lot of it's about, especially when it's kind of improving processes like this, there's usually lots and lots of ideas from staff, from management at various different levels about what could we do. And simulation, as much as anything, can act as that facilitation tool and help you prioritise those ideas and sort of try and assess that kind of impact and get a shared kind of understanding. Because we can run it forward and we can tell you, okay, it's going to make a difference over a week of this, over a month, over a year, over 25 years. Do you know what I mean? That, if you have to wait and do that in the real world, you're going to be at minimum 6 months, maybe a year on to finish a prototype, to then be going out. So are we going to get it absolutely perfect with the simulation all the time? No, but we can accelerate and we can make sure that what you implement has a far, far better chance of success, and knowing that really, really quickly. And particularly in today's climate, when we're all facing huge backlogs and whatever else, it's just, we need that speed and that agility to make an impact quickly.
Oh my gosh. Okay, so I have like 4 different questions swirling in my head, so I'm going to try to prioritize which one I ask first.
No pressure, Julie, because Tim will just string them all together, so really the bar is super low for you there. Yeah.
I'm going to try. Be really clear. Okay, my first one that came to mind was like how... Okay, when you're talking about even a hospital system, just that example, like to keep building on that, I mean, there are just so many pieces of information and like business rules. So like the consultant, what do they do? How many years of experience? What is the experience of the people staffed in the ER? How many are there? How many people are influxing? What is their issue? Like, what is the patient's issue coming in? What is their process for someone that has a broken leg compared to like 104 fever, who's, 3 compared to 60? Like, how in the world do you get all of the rules to like actually define the system? Like, to me, that's like infinite amount. And then it blows my mind that you can build the simulation. So how do you talk to stakeholders, get all that information? Hopefully they're collecting enough of it too. Like you get in situations where there's these realities that how do you even represent them? So my brain was kind of going crazy thinking about that. Like how?
Yeah, and so it comes back to that understanding the question and understanding the question you're trying to answer of the simulation, and so therefore how much of this, how much do I need to model this accurately? Because I don't need to make this a 100% sort of accurate simulation. There are cases when we have done that and can do that, but you don't always need to go that kind of far. And the reality is that, simulation engines like ours are really, really sophisticated. So we actually can model all of those types of rules that you're talking about. So we can put in the different kinds of staff, we can put in their experience kind of level, and we can say how that impacts on the time that it'll take them to do sort of steps in the process and things like that. So we can do all that kind of part. Some of it relies on, sort of interviewing kind of people and doing that kind of part, but that's also where you get a lot of the kind of insight. Back when I started consulting, sometimes you stood on the manufacturing line with a stopwatch to collect the data. We're in a different world now. Often the problem is, whoa, that's a lot of data you've got all kind of that. So I think there's lots of different things going on. So I think it's understanding how much you need to model that. And I think the process is it's speaking to people, it's understanding the data, and then sort of understanding which rules are the important ones. And sort of then what you do is you keep doing a process of validation and verification so that until you're getting it to the point where it's representing enough of the behaviour in the real world, then I can start experimenting. But just to blow your mind a little bit, kind of more and add another bit of complication, where simulation has got really much more sophisticated now, and I think it's a real step change, and what will make this a much more accessible technique to people and also a quicker technique to do is that now, if you imagine like our little steps, if you imagine our simulation looks a bit like a flow chart, and we've got this one step, somebody's kind of coming out of triage, where do they go next? You're right. In the sort of old days, we would have written in all the sort of the different rules and the logic as to where they're going to go. But now we can sort of call on machine learning algorithms, and we can sort of plug those in, and we can say, right, okay, last time we saw a patient of type X exhibiting these conditions and these diseases, they went down path A, put them down path A. The next one comes down path B and stuff like that. So now you've got the flow of the simulation, you've got your data sets, and all you need to do is tap into that data set. So the time to build the simulation radically comes down. The accuracy probably will increase as well, because there's a lot of nuances. Where it becomes really complicated is things like, why does a consultant send somebody somewhere? Not because there's probably a gut reason, not necessarily something he can articulate often as to, or why did I put that patient in this bed versus another with bed managers. So the power of that machine learning stuff to really step change and make this much more accessible to people is that's the, well, it's not even the future, it's the current, but that's what's happening now.
Gotcha. That's amazing. Because then, okay, so then even thinking you're running this into the future of like 20 years, whatever, to see the change, could you then use machine learning to possibly also help like represent the changing patient population you may have? Like, would you ever have to do that if you're like trying to run it so far into the future where you're like, I can't assume my patient population, or maybe even partly the staff, like is going to look exactly the same. So does that help there as well? So
what I would say is that there's always a time frame that you run simulations kind of on. And so, for example, an A&E department, you would probably run a week, maybe a month, but run it repeatedly again and again and again, because what it's about seeing the sort of the variability and seeing how often does the work come in and where does it exit the system. And so most of the time nobody's staying in A&E kind of department for a long time, so you can sort of rerun the same kind of week or the month and sort of do it again and again and again and again. A factory, you would run whatever their schedule of orders are. But you're right, there are other situations and other simulations that you then run over these 25-year periods. And so population health is a really good example of that. So I think a lot of the examples we've used just now are very sort of operational process kind of focused, but these same simulation techniques get used at a much higher level, almost like at a policy kind of level. So sticking with the healthcare example, another good example of that is managing your ageing population or managing people with long-term conditions. So if you've got a long-term condition, you're going to be in the health service, not just for one iteration, it's going to be for a long time period. How effectively we treat you at the start of that long-term condition might impact your sort of journey sort of much, much further kind of on in the system. You're right, then different populations, the geography that somebody lives in can affect the makeup of the population and their health of them. The services that are available in that geography will then also kind of impact. So that's an example of a type of simulation you would want to run it over sort of 25 years because you're looking at the lifetime of the patient and the lifetime of the population. And some of those simulations they're much more abstract, and you're not dealing with so much of the individual kind of rules and things like that, but they're fascinating. They're fascinating to see how you make a change here and then it impacts sort of 20 years down the line. And then even sometimes creates problems. The better we treat long-term conditions, the more demand there is on the hospitals because we have more people that are still. So there's all sorts of incredible policy kind of type simulations you can do as well.
Wow. Okay, I have one other one, but Tim, I will pause because I feel like you have a question.
No. Go ahead.
Okay.
Continue.
Last one that blows my mind is like the assumptions going in or like the unknown relationships that just are. And I know you mentioned machine learning, so maybe this helps with some of it. But I keep thinking of this example. I was just talking to actually our other co-host Val the other day, and we were having this whole conversation about like levers people in an organization can pull, right, to move a KPI the business cares about.
Yeah.
And she was giving an example from one of her previous market research jobs, I believe. And she had said how they had done this study and they found that if at a call center, people had their call answered within 30 seconds of them calling, like the end satisfaction and whatever else they were measuring was like way, way better. So they report this piece of research back to the client that they were working with. And so they implement it in their call centers. Well, ends up what they did in reality, right? Like that I don't know if we would have seen if we were simulating this. I don't know. They were answering within 30 seconds because their manager told them to, and then they were putting them back on hold. So people actually were really pissed. They were not happy. And the results they thought they were going to see, they weren't going to see. So that's like obviously a small example, but how do you guys approach things like that? Like you have an assumption going into your simulation. What happens when like unforeseen things come up? Or have you run into like an example like that where the simulation said one thing, but then it hit the reality of the world and it was a little different or really different?
Yeah, we call it sort of moving the problem. And I think when people look at a lot of these process problems and then sort of end up implementing the real world when they haven't done something like simulation, you hear that story again and again and again. The classic example where you used to see it kind of again and again is that on a manufacturing line, a sales guy would come in and convince you to buy the super duper new deluxe machine whose run through rate is 20 million parts per hour. And you think, fantastic, this machine solves all that problem, it's got a big bottleneck there. But the next machine can only process things at 100 parts an hour. Well, okay, the process can only run as fast as the slowest machine in the process. So, and in your example, the way that would have got caught in a simulation is that you would have been looking at sort of overall performance results. So you would have been looking at the time of the customer in the system as well. So then you would have seen, right, okay, my first response time, yay, fantastic. But actually their time in system either hasn't gone down or possibly worse, it's increased because I've front loaded all my staff kind of now.
Gotcha.
So it's that type of stuff. That's what I mean about it being like a journey of discovery a little bit, so
yeah.
The simulation looks like a flow chart, but then we have, if you imagine almost like red sort of balls kind of storing up in front of steps, and that sort of visualizes bottlenecks and things like that. So a big part, you're sort of running the simulation and go, right, okay, look, great. All these customers are kind of coming. Hang on a minute. Why is there a big stack of red balls kind of here? What's going on here? Okay, let's dig and investigate a little bit. I've moved the problem. That's what's going to happen. So now, okay, now I'm back to the start again. I need to try another idea, what I experiment with and things like that as well. Yeah, or, to use that example, then to use how they might have kind of solved it. What I've seen in some call centres, unfortunately, have modelled them is what they actually then do is say, okay, the last customer in is the first customer call that we will answer, because then hopefully we will satisfy them a bit more. We will still lose a chunk of them, but we satisfied this chunk. Is that okay? And so that's what I mean about you can catch a situation and then it makes you think about it in a different way. It's just that ability to experiment with something and really see the impact. And it doesn't need to be 100% accurate to get that aha moment. It just needs to be accurate enough to catch the dynamics of what's happening in the process.
Man, I'd be so mad if I was that caller that got cut off the top. I'd been waiting 2 hours and they took the person that called last.
But that's fine.
Yeah, it's in the KPI.
Yeah.
It's where the danger of averages, or whatever, the median, that's when you get into what's your median wait time versus your average. That poor sap who was on the call for 4 hours.
Yeah, and I'm the worst person. Like when I'm in a process, or like if I'm standing in a coffee shop, honestly, I'm standing there just going, listen, I can fix this for you. There's a reason your queue is built.
Oh no.
Yeah.
This knowledge is dangerous.
Yes. Disneyland. My husband hated going to Disneyland with me because I'm standing there and I'm going like, oh, that's really clever. They've made the queue like an entertainment zone, huh? He's like, enjoy the ride. This is not what we came to Disneyland.
I mean, it does seem like almost from you clearly, and I feel the same way. Like it feels like you get a lot of like joy from going in and just trying to break down like the pre-work, ultimately we're going to do a simulation, but I'm going to get to actually understand your process and have a conversation with the domain experts, which seems like that has very, very broad application. And you have, in some of our sort of pre-talk about this, you had referenced that sometimes, not to put words in your mouth, like you get the most value in just getting to the point where you can build the simulation before you actually build it. Just doing the discovery with the client. Can you talk about that a little bit?
Yeah, I think so. I think there's a misconception in simulation that goes back a long time, that it's about this sort of hard number crunching kind of analytical kind of tool, and it can be, and we build a lot of simulations in that way, and there's definitely kind of a place for them. But there's what I would describe, and I think a lot of data scientists just in general would identify with this. There's sort of the art of simulation is the way I would refer to it. It's all the soft parts that go around it. It's just the skills that you learn in terms of like being a consultant, being a facilitator and everything else. But simulation is a very unique tool in that way, because it has the power to just get people talking and get them thinking about things in a different way, and letting them see. I think a big part of it is the visualization. It's letting them see things that they maybe can't, because often, like in a modern day world, I mean, a call center process might span 4 or 5 different countries, because calls are being farmed to different parts of the world at different times of day, depending on what the kind of. So you can't see your process anymore the way that you could in the olden days, and sort of now where you were just on the factory floor or whatever else. So processes have got more complicated, and businesses got more sophisticated. And so, yes, a big part of what I know our users do, and our kind of team do when they go in with users, is just talking it through with them, and sort of, and you get a lot of the joy out of that, the problem formulation, and there's a lot of value kind of in that, and just kind of getting that to the point to the understanding. And sometimes simulations even used, and the end goal is not to build a simulation, it is just to go in and get people around the table and just get them talking about ideas, see something that can kind of come behind, or get behind, and do some experiments with it. So there's a few different examples where I've seen that done. I've seen that done with when sort of some sort of government kind of changes have been coming out, and they've used it as a facilitation tool with the public to sort of make them understand why they're making a decision that might be kind of a bit more controversial. Look, here's what we think the impact will be. This is what we're trying to do, and we've been sort of analytical about it. I've seen it where people, they just need to get a shared understanding across an organisation. They maybe have different departments whose processes kind of come together, but they all work in isolation. So I've seen them kind of come together and kind of go, oh, right, okay, so when I make this decision here, it knocks on to you 2 months down the line. Ah, right, okay, yeah, didn't get that. But why would they? Because they can never see that. These departments are working in isolation. Or equally, we've seen it maybe sometimes in sort of healthcare services where they've just wanted to come together and just get everybody thinking, what can we do differently? How can we approach this kind of problem differently? So the simulation lets them see what they're doing, and then radically just sort of quickly check some different ideas and then go, okay, right, this one works, this one doesn't. And yeah, it's the people parts of processes and data analysis, they're often the most frustrating, but the most rewarding parts when you really help somebody get to that aha kind of moment. It's what it's all about.
It seems like a really sneaky way to get people who maybe don't inherently think process to actually talk process, because it makes it feel like they're doing something.
Yeah. And I think to use the coffee shop example that I gave, to go back to it, right? So that, when I'm standing sort of in a coffee shop and I can see them starting to make my coffee first. So my orders come in, I've got coffee, and I'm getting my sort of panini sandwich sort of thing that needs to go in kind of the oven. And I can see them diligently trying to make my coffee, but the slowest part is actually making my sandwich. So why I start making my sandwich first, then come back and make the kind of coffee. Now, I'm making a joke, and that's a really small kind of example, but I've been looking at processes for 25 plus kind of years. That makes me feel so incredibly old, but the reality is, so there's loads of stuff that's just intuitive kind of to me, and some people's minds work in that way, but we don't need nurses to be process experts, so that's where a simulation can kind of come in, and it can show them things that are a little bit differently and just sort of make them realise, all right, okay, if I change the order I do the steps in, or if I bring all this equipment into the one room so that I'm not having to go to different places, that times the 50 times I have to do it today is going to add up to a big part. So it's almost like a learning tool. So it's abstracted from the day to day. So you need that. We can't help people improve processes when we don't have the access to the experts of those processes. And those are people that are doing the job and they're doing the hard job. But what we can do is help show them, right, look, but if you change slightly what you're doing, you can get more out of your system. You can get better performance.
And it seems like to start the process, you need some sort of a going in question or like, we know we have this problem that we're trying to solve. But also, how often is it true that in the process of doing this simulation or whatever, people will actually find new things they never thought of? And then how do you determine the validity or whatever of like, okay, yeah, that's something we should address or whatever? So like, I don't know the right way to ask that, but hopefully that makes sense.
Yeah, no, it does. And it's all the time. It's all the time. You know, and any piece, any kind of data analysis that you do, I think that's kind of true. Or you start off with one question, you learn something, you pick out a bit of insight, and that kind of takes you down. So you have to, I think that's where it comes back to sort of the process that you've got around. So yeah, trying to think of that kind of core question that we were answering. And it's a bit like the sort of the build, measure, kind of learn kind of loop that we do sort of in Startup. It's very kind of similar. Okay, what's the question we're trying to answer? Let's build the simulation, do enough of the data analysis to answer that kind of question. What have we learned? Okay, now next, a second iteration. Is the question we're asking still valid? So we've got further work to do and go around that. Or actually, is there another better question that we should be answering? And so it's continuously going through that kind of look. Now, I'm making that sound really easy to do. It's not. We all get distracted and we kind of go, oh, this is really good. But in principle, every time you have to just keep coming back. Okay, what was the question? Have I learned enough? Okay, are we on our next kind of question? And that's what I meant earlier about it's not necessarily one big simulation, because we might throw the simulation away in each of those cycles. So it's just about doing enough to answer those questions and move on to the next part.
And then do simulations provide the ability to give like a scale of change or like this impact level? Or is it like, so I don't know, Tim, you're better at this, like, basically, like, if I run the simulation 50,000 times, it'll tell me that if I change this part of the process, it'll improve this by 15%. Like, how much is that predictive, or how accurate is that? Or do you have to sort of do like, can you, in other words, like, does it give out accurate results, I guess is the right way to say it.
Yeah, it does. And so that's part of the sort of the validation and verification process. So you can build a simulation for a process that doesn't exist, and you'll get a lot of value from that. But typically what people are doing is that there's a process that exists, and so they're building the simulation, and what you do kind of first is kind of go, right, okay, these are the sort of the inputs I've got, these are the sort of the key results I'm looking at. Does this match what I'm seeing in the real world? And so you'll keep going back and sort of honing the simulation until you get those kind of output KPIs reflecting what you would see in the real world. Now that's where the caveat comes in. It doesn't always need to be exactly like 100% kind of accurate. There's a scope, and it comes back to, you know, exactly, am I all right with them being sort of within 10%, or is this number so critical that I need to get it down to the 1%? So there's a bit of, the figuring out what's the kind of the right kind of level. So then once I've got a simulation and it matches what the world is, and it's the accuracy, then I can start making changes. And then where simulation really comes into its own is that we can rerun the same week 1 time, 10 times, 10,000 times, 20,000 times, 50,000 kind of times, whatever, however many times you need to do. And the more runs that you do, the more accurate it will be. And then what that ensures is that you've not run it for one good day, you've not run it for a bad day, you've not done it for an awesome day. You've taken into account the range of days that you're going to get, so that you're able to then predict overall how the system will perform. And how many runs to do is a question we always kind of get asked, and that's down to how much variability is in the kind of the process. So there's some processes, you might be running a really long process for a year, so therefore you don't actually need to do that many runs, or you might be running 1 week, but there is an awful lot of variability in it, and so you want to do lots of runs. But the good thing is, it's still really, really fast. You know, so I've built simulations that run 25 years and 25 seconds. You know, so it's not like these runs are going to take days and weeks and months to do, because simulations are valuable if they can be built and run as quickly as the decisions a business needs to make, and at the pace that the business needs to make the decisions, because otherwise you're going to go on gut instinct.
I'm the other question that's sort of in the back of my mind is around sort of uptake of decisions or information. So one thing that exists in the world of analytics for sure is sort of people have preconceived notions of what they think the result is or should be. And certainly when we do other analyses or predictions or things like that, people will have a hard time believing their data scientist or analyst or whatever. I don't know if you feel comfortable comparing and contrasting, but I wonder, like, to what extent do simulations help or hurt, or do they feel the same? Like, what has been your experience? I mean, I've literally watched executives watch a usability lab test and walk out thinking that user is so stupid, instead of taking in the idea that, like, no, the user's confused by your terrible system here that you need to then go address. But it's sort of like they just can't put their mind around the idea that, oh yeah, maybe it's my problem or my fault or my idea is not the right idea. I don't know. I'm just curious what your experience has been there.
The phrase I would use to describe that is that you're telling them their baby's ugly.
Yeah.
It's that.
Nobody likes to hear that. Yeah.
Nobody likes to hear that. So there's a lot of it. But I think, it's trust, isn't it? It's trust, and it's sort of building up that kind of trust. And I think that is always a challenge. I think that's a challenge in any kind of project, because you as an analyst get so deep into kind of the numbers and you really understand all the parts and you know how you built the kind of system, but you're asking somebody to trust in that kind of black box. I think that's where simulation does have some advantages, because you're not just presenting a chart and then I have to trust that you did the right analysis to produce the right kind of chart. The simulation's visual, and so you're seeing something that looks like your process, and we're going to engage with you. And a big part of the simulation project would be working with you as a stakeholder and saying, what do you want to try? Okay, you want to try this idea, you want to try that idea. And so we'll build little interfaces on top so that they can just radically kind of try lots of different kind of scenarios kind of out. And that allows them to go on a journey of discovery themselves, but also sort of get a bit of exposure to what's happening behind the system and therefore build trust in it so that outcomes are more likely to be implemented.
And I think that might be it right there. A simulation visualizes out this process where sometimes I think as analysts, we don't get credit. And sometimes analysts don't fully understand the process themselves. And so their analysis focuses on one aspect of it, but misses other pieces. And maybe that's where this can become a very powerful tool potentially then.
Yeah, definitely.
Interesting.
It's...
All right. I'll let Tim and Julie get back to the science questions.
Perfect. No, just kidding. No, because I actually do have one that's like maybe a little left field compared to some of the questions we were just talking about. You mentioned something. Oh, Michael, when you first asked your question about like when you're designing it and like the accuracy and the ranges, and you mentioned, when you're building the simulation, you're looking for a tolerable range, like on those KPIs, those outputs you care about. And so it made me think, and I'm guessing Tim thought the same thing. Is there an idea of overfitting in building a simulation?
So by overfitting, you mean having made it too perfect?
Yeah, like when you're doing a model, if it perfectly matches the training, it's like too sensitive, and then you put it with like your test data, and it's going to go kind of crazy.
No, it's a good question. It's not what I've asked before. Do you get overfitting?
Well, I guess like if somebody says, "Oh, you said we took our test data and we put it in and we're within 10%," and the client's like, "No, keep iterating on the simulation," and you keep tweaking things and say, "Well, now with our test data, the simulation is within 2% of reality." But I mean, it sounds like you would have your spidey sense tingling, saying, "But wait a minute. Now when I make this change, I might have like over modeled the exact understanding of the history, which means when we try to change something, it may not be a good reflection."
Yeah, I think there probably is an element of that. I think more where my comments come from is that it's the time that it will take to get the additional accuracy of 2%. Is that a worthwhile investment in terms of is it going to make the simulation significantly more accurate? The input affects the outputs, but it means the delivery time of the simulation is much kind of slower. And so, and it comes back to that, what I was saying about the, simulations when we're a lot of our customers, some of them, that's all they do. Some of our users, they're just building simulations all the time, and they're supporting business with the decisions being made all the kind of time. So they need to do that really, really quickly. They can't be going back weeks later with the sort of the decision, because the manager of the process had to make the decision already. He had to do it yesterday. We all have to do that. So there's an element of just, that's what I mean about it, and it's sort of the art of it is just making the simulation kind of complicated enough. But there are times, and I think simulation is moving into different fields now where it's not about sort of building one-off simulations. What a lot of customers and users of it are now doing is sort of building operational tools. And so the simulation's effectively making decisions in their process. Okay, what is the right bed to place a patient in? And it's sort of helping with real-time decision-making. Those simulations need to be 100% accurate. And the time that it takes to get into that is worth it, because that simulation is going to be used 50 times a day plus, or sort of, kind of, and there's lots of different use cases of that. So it's like a data science kind of project, in that kind of sense. And does the extra effort get me extra value?
If you're going to spend so much time building the simulation that you could have just run an experiment, a well-designed experiment, and gotten the answer, then maybe you spent too much time trying to build the perfect simulation, I guess. Interesting.
Yeah.
Okay. The one big question, I know we've talked a lot about like simulation, what it is, how you do it, where you use it, but I would love to hear, and I know you talk about this a lot, I believe in some of your talks in other places, but like, where is the technology of simulation going next? What's the future of simulation?
Future of simulation, yeah. That is the stargazing blue sky part. That's one of my favourite parts of my
role. Have you built a simulation to simulate the future of the different ways that simulations can go?
Well, we built a lot of simulations internally for different things, but not to simulate the future. I get to blue sky. Where's the future of simulation going? It's that shift. We're moving from using simulations to make one-off decisions to make real-time decisions, and that's already happening. So people are already doing that, and it's the ability to use process mining, so a technique that's going to allow you to analyse the data and find out the process flow. Then we've got machine learning, which can come in and mean that we can get the decision rules automatically. So now we can have self-building, self-adapting simulations, which means that a simulation can never go out of date. So we can now put it in the heart of tech stacks within organisations to make decisions. And so that can be about understanding on a weekly basis what's the best sequence to put the cars through down the production line to make sure we hit our orders. It can be about a bed manager in a hospital understanding that, okay, like the simulation's running for them and saying, right, okay, based on the emergency arrivals that are forecasted, the planned surgeries over the next 2 weeks, the beds that are available, the rules that are there about gender, whatever else, put the patient in bed 341, because that's going to be the most efficient for today, but also for next week's running of the hospital. So it's that real-time decision-making, so we can do that. But then where it's going to go and where it's leveraging up is then that we are running the simulations forward, and we can tell you in advance, there's a problem coming. A week, 2 weeks down the line, we've got a problem coming. We've done some scenarios for you. Here's what the corrective and preventative action you can take so that you're never going to get into that crisis situation. And that's where the future's going. So cognitive simulations.
I have so many more questions now.
So that would be like if your simulation has said, if you go back to the hospital example, that when you say, well, let's simulate a shock to it, a pandemic or even just a large high injury count, and we've got the simulation, we've got this working well, but if this shock happens to the system, the wheels are going to fall off. So now let's do our disaster planning with that sort of thing. and say, if this happens, then we need to do something else.
Yeah, and you can already do that. So have your disaster plan. That's a big use case for some what people kind of do. But it's probably those things that sneak up on you. Actually, there's just been a really high incident of emergency arrivals into kind of the ER department over the last weekend. Turns out it's because there's been some mad music festival and something's all kind of going haywire. We've got all of the kind of like people kind of coming, but it's going to ripple on through the hospital for kind of weeks and weeks to come, because now we've got patients through the hospital. So now we've got an elevated bit, but we've still got all our planned arrivals. It's also Christmas kind of time, so we know arrivals are always heavier at that kind of, so it's that kind of type of stuff. Okay, right. It's understanding that there's all these sort of inputs that are changing and coming and kind of shifting, and if they can come together and they can collectively, so sometimes it's more the small things rather than the big things. It's the small things that are coming, because people spot the big disaster, they spot the earthquake that's happened. They don't spot that there's this myriad of little things that
the little thing that's gonna.
Yeah.
How do you sleep at night? My brain would just be going forever, like living in that world. I already feel that way. I'm like, good thing it's 7 a.m, like my shot of caffeine, because now my brain's just like turning.
Yeah. There's a lot of screaming at TV screens, I have to say. You're just like,
the curse of knowledge.
Right.
All right. Well, we do have to wrap up. This has been an amazing conversation. Thank you so much, Frances. This has been awesome to talk about this topic with you. It seems like a super powerful tool in the arsenal of a data professional, and it seems like well worth it to take somebody from the team and really get them focused on this and leverage this kind of capability. All right. Well, we have to start to wrap up. And one of the things we love to do is go around the horn and share a last call. Something might be of interest to our listeners. Frances, you're our guest. Do you have a last call you'd like to share?
I mean, first of all, just to say thank you for having me, and I've enjoyed it as well. But yeah, my last call would be that simulation can do a lot of good in the world, and we did a lot of good during COVID. We did a lot of pro bono work to help, and that, particularly as an organisation, we do want to help, because we know that this isn't always accessible to everybody. So, if people are working in the third sector or kind of whatever else, then we've got a Tech for Good programme. Please do get in touch and let us help you if we can.
Very cool.
Yeah, that was like almost a whole other potential topic, was just the Tech for Good and simulate it. We're like, that could be.
We'll include a link to that in the show notes as well on the site, so people can check that out. Thank you. All right. Well, Julie, what is your last call?
My last call is like weirdly on brand for this, and I really didn't think about it until last night. I was like typing up more notes about it, and I realized it's a simulation. So I thought that it worked out well.
Nice.
It is an article by Duolingo about a simulation they built to figure out how to move their daily active users' main KPI. They had kind of seen a lot of growth in their initial years, and then it was kind of becoming stagnant. And so they actually built what I think they call it like their growth model. And I love the article. It was really well written. It was really simple and straightforward. And I thought it was really, one, interesting. Two, it opened my mind up to, I think, a lot of things that are applicable to what I'm trying to do at work. And then, of course, realizing it was a simulation. It was really cool to see how they were trying to figure out what other metrics can help us move our daily active users. And so by building out their whole process, mapping it all out, running a simulation on it, they were able to kind of figure out which other metrics to go target, and they've seen huge success from it. And then they talked at the end about how they're trying to actually make it more in-depth and like future-proof it for the next time daily active users kind of becomes stagnant, because, they know they can't grow to 100%, whatever that may be. So I thought it was a great article.
Awesome.
Nice.
Yeah.
So
what about you guys?
I'm getting to that. No, but I'm just, you're setting the bar so high by like tying it into the show topic and everything.
I really didn't mean to.
No, I
was
mean,
lucky.
But own it. Just take it. Just take the victory lap. It's awesome. You're natural. Okay. Tim, what about you? What's your last call?
Well, so I was going to have just one, but now since I've got one I can tie into the show, I'll do a quickie. This was, again, I kind of realized that, this was sort of this was a little bit of a slightly different simulation, but what goes back to Merritt Aho had started working on it. It has to do with sequential testing, like if you're doing classic A/B testing and don't peak. And Merritt started asking like, well, what happens if you do peak. He didn't invent sequential testing, but recently, a month or so ago, Matt Policastro did a presentation to the Test and Learn community where he talked about sequential testing, but part of that was he and Merritt had run sort of simulated, like what would happen? What would your false positive, how would your false positive rate be affected if you peaked early without changing some constraints? So I just have that picture in my mind of them showing all of the simulated tests and kind of what would have happened, and therefore what could they do to correct for that, and that introduced sequential testing. And I'm probably butchering it, but it's on YouTube as a video, so we will link to that. But my non-simulation last call was Nick Potter on the Measure Slack posted this, and it is 100.datavizproject.com, viz with a Z. But it was, these guys took a 6 data point data set and they visualized it 100 different ways, which sounds crazy, but they were just kind of like, how many different ways with just the simplest of data sets, how many different ways could we visualize it? And they came up with 100 different ones. Some of them I don't think anyone would recommend, but they're all pretty polished little vignettes. And it was kind of an interesting exercise to think. I mean, I first read it and said, you can't possibly, these are going to be like simple little derivatives. They're going to have to be cheating. And no, they came up with 100 distinct visualizations. So it was kind of a thought experiment taken to an extreme that's worth checking out. And you, Michael?
Well, I'm so glad you
stop
asked.
With 2. Unless you want to skip, since I did 2.
No, that's okay. No, I do have one to briefly I'll share. So the Digital Analytics Association, of which I've been a part for many years, they're having an executive leadership forum coming up in April 26th and 27th. So if you are an executive leader and you want to talk to other executives about simulations specifically, I suggest you go and attend that. I don't know if that's one of the topics, but now that you've listened to this episode, I think you can go there and make it a topic at the Executive Leadership Forum. But we'll put a link to that in the show notes. It looks like it'll be a very good event to just, think through some and talk to other leaders in different places, in different spaces about analytics challenges and solutions. So, all right. Well, this has been awesome, and we've really love to hear from our listeners. So if you're out there listening and you have questions, you have thoughts, we'd love to hear from you. It's the best way to do that is to reach out to us on either LinkedIn or the Measure Slack group or Twitter, and we'd love to hear from you. I don't know, Frances, are you active on social media at all? Is there some place where people could follow you or
you can find me on LinkedIn or on Twitter.
Perfect.
Simulation.
Awesome. All right. So I would say, probably go follow Frances as well. It seems like the wealth of knowledge lives there. So anyway, no show would be complete without a shout out to our awesome producer, Josh Crowhurst, who works behind the scenes and sometimes in front of the scenes to make this show happen. So Josh, thank you very much for all you do. And once again, Frances, thank you so much for coming on the show. It's been awesome to have you. Thank you for handling all of our questions and teaching us a little more about simulations today.
Well, thank you for having me. It's been great fun. And you guys have asked really good questions. Really good questions. Thank you.
Awesome. All right. Well, I know I speak from my 2 co-hosts, Julie and Tim, when I say no matter what the process looks like and the number of simulations going through it, just remember, keep analyzing.
Thanks for listening. Let's keep the conversation going with your comments, suggestions, and questions on Twitter at AnalyticsHour, on the web at analyticshour.io, our LinkedIn group, and the Measure Chat Slack group. Music for the podcast by Josh Crowhurst.
So smart guys wanted to fit in, so they made up a term called analytics. Analytics don't work.
I love Venn diagrams. It's just something about those 3 circles and the analysis about where there is the intersection, right?
I remember when I was in college, I worked at a Starbucks, and I would work there, and I was
that explains so much.
Yeah, and I'd work at, you'd be at the cash register getting people coffee, making coffee, and I was like, someone has had to have done some sort of modeling of who works where in what position in this store to make the flow work correctly. And I was like, I was just in my back of my mind, I was like, they probably did process simulations to basically say like, all right, we need one employee to be here, we need to put this here, we need to put this here. But yeah, when they added the sandwiches to Starbucks, I think they threw it all out of whack, and then they make your sandwich at the wrong time. It's a huge problem. I think you're so right.
And that's when Starbucks became horrible.
Oh, well, no, it's when they took out the actual barista make machines and made them all automated. That's when it all went. So, yeah, terrible, just terrible. Used to be an art. Used to be an art to it.
Supposedly, I heard that Waffle House has like some really impressive process they follow. Like they speak some like shorthand to each other, like this crazy. If you listen, I mean, I don't know if there's any Waffle Houses around you to easily go to, but
I mean, there are around
my
me.
My daughter loves Waffle Houses. So
I just know my mom and my stepdad were telling me they're like, we sat at like the bar seating and you could like hear all of them talking and the waiters, and they speak in like numbers, letters, and where you put the toast tells you what order it is, and they're like, it was amazing, and everything came out so fast. So they know something.
It's no Disney. It's no botched cues at Disney. That's for sure.
Yeah, well, I think they've really made an art out of it. But it's also like when you're sitting at a traffic light and it's way too long, and you're like, who planned out this intersection? And, all that stuff.
I worked in the traffic signal industry when you were doing your baristaing. I was in the traffic signal. So we could talk. Rock flag and faster coffee through simulation.